Hello friends, good afternoon everyone. I am fine. How are you? I hope you will be fine. Welcome back in my channel, Dr.Satendra Kumar. Dear friends, if you want this type of videos related to mathematics for higher level, then you need to subscribe, share and like my videos and my channel. Today we will discuss sequence and series, that is Convergent, Divergent series and Fourier series. There are some short type question. Question number first, to show that log 0 equal minus infinity. Solution: let log 0 equal minus infinity is a true statement. Now taking antilog, that is 0 is equal to e to the power minus infinity. We know that limit n tending to infinity x to the power n equal to 0 when x less than 1, equal to infinity when x greater than 1. Now right hand side, e to the power minus infinity equal to 1 upon e to the power infinity. Since e is equal to 2.718 greater than 1, this is equal to infinity, this is equal to 1 upon 0, 1 upon infinity, that is 0. This is equal to left hand side. Hence, log 0 equal to minus infinity is a true. Proved. Now question number 2. What is convergent series? What is convergent series? Such series whose sum is finite, whose sum is finite, is said to be convergent. Now next question, question number 3. What is divergent series? What is divergent? Answer: such series whose sum SUM is infinite is said to be divergent series. Question number 4. Discuss the series summation 1 upon n to the power 5 by 2 is convergent or divergent. Answer: we know that summation 1 upon n to the power p is convergent if p is greater than 1 and divergent if p lesser or equal to 1. In this case, test is not valid. Hence, summation 1 upon n to the power p by 2, 3 by 5 by 2. Since 5 by 2 is greater than 1, that is always a convergent series. Now question number next, that is question number 5. What is Cosy nth root test? What is Cosy's nth root test? If un limit n tending to infinity, un whole power 1 upon n, limit n tending to infinity greater than 1, series is divergent. Less than 1, series is convergent. Equal to 1, test is failed. This is the Cosy nth root test. Radical test is another name of Cosy nth root test. Radical test is another name of Cosy's nth root test. Now question number 6. Write down statement of P series test. Write down statement of P series test or hyperharmonic test or hyperharmonic test. This is the another name of P series test. Statement. The series summation 1 upon n to the power p, that is 1 upon 1 power p plus 1 upon 2 to the power p plus 1 upon 3 to the power p plus 1 upon 4 to the power p plus up to dot 1 upon n to the power p plus dot dot is convergent if p greater than 1 and divergent if p less or equal to 1. That is P series test or hyperharmonic test. Both are same. Now question number next. Question number 7. What is D'Alembert test? D'Alembert test or ratio test. This is the another name. Answer. Let summation un is a infinite series, is a infinite series if limit n tending to infinity un upon un plus 1 greater than 1, series is convergent, less than 1, series is divergent, or equal to 1 test fail. Now question number 8. Write down statement of rabies test. Rabies. After failure of D'Alembert ratio test, we apply rabies test. Let summation UAG in infinite series then if limit n tending to infinity n un upon un plus 1 minus 1 equal greater than 1, series is convergent, less than 1, series is divergent, equal to 1 test fail. Now next question number 9. Define De Morgan and Bertrand test. De Morgan and Bertrand test. Answer. After failure of rabies test, then we apply De Morgan and Bertrand test. De Morgan and Bertrand test is limit n tending to infinity n un upon un plus 1 minus 1 bracket close log n greater than 1, series is convergent, less than 1, series is divergent, equal to 1, test is failed. Now next question number 10. What is logarithm test? Logarithmic test. Answer. Logarithmic test is used only when un upon un plus 1 has higher power in n. That is logarithm test, limit n tending to infinity n log un upon un plus 1 greater than 1, series is convergent, less than 1, series is divergent, equal to 1, test is failed. Now again repeat. When un upon un plus 1 has a higher power in n, then we apply logarithm test. Now question number next, that is question 11. Write down higher order logarithm test. Write down higher order logarithmic test. After failure of logarithmic test, we apply higher order logarithmic test. The test is limit n tending to infinity n log un upon un plus 1 minus 1 minus 1 log n greater than 1 series is convergent. Less than 1 series is divergent. Equal to 1 test fail. Now next question number 12. Define real sequence. Answer. A real sequence is a function whose domain is the set n, capital N, of all natural number and range a subset of the set R of real number. Now repeat again. A real sequence is a function whose domain is the set capital N of all natural numbers and range a subset of the set capital R of real numbers. That is mapping F such that n tending to, that is natural number tending to real number. Such mapping is known as real sequence. Question number 13. Give an example of convergent sequence. Answer. Let 1 upon 2, 1 upon 2 square, 1 upon 3 cube, up to dot 1 upon 2 to the power n dot dot is a sequence. Therefore, nth term of the sequence 1 upon 2 to the power n. That is taking limit n tending to infinity both sides. This is equal to 1 upon 2 to the power infinity, 1 upon infinity, this is equal to 0. It is a finite. That is the sum of the given sequence is finite. Hence, sequence is convergent sequence. Sequence is convergent sequence. Now, question number 14. Give an example of divergent sequence. Answer. Let 1, 2 square, 3 square, 4 square up to dot n square dot dot is a example of sequence. Let nth term of the sequence is equal to 1 upon n square, taking limit both sides an, this is equal to limit n tending to infinity n square, this is equal to infinite, hence sequence is divergent. Sequence is divergent. Every sequence whose sum is infinite, then sequence is said to be divergent sequence. Now next question number 15. Give an example of a monotonic increasing sequence which is number first convergent, number second divergent. Now answer. Let the sequence, first part, let the sequence 1 upon 2, 2 upon 3, 3 upon 4, up to dot, n upon n plus 1, dot, in which the terms are 1 upon 2 less than 2 upon 3 less than 3 by 4 up to dot. The sequence is monotonic increasing. Then sequence is monotonic increasing. Full stop. We take another term of the sequence, that is n upon n plus 1. Now taking limit n tending to infinity both sides, this is equal to limit 1 upon 1 plus 1 upon n. Now n cancel by after taking common. This is equal to 1 upon 1 plus 0 is equal to 1. It is finite. That is, sum of the sequence is finite. That is, sequence will be convergent. So sequence is convergent. Now second part. Let the sequence 1, 2, 3 up to dot n, dot. Since their terms are 1 less than 2 less than 3 less than dot, the sequence is monotonic increasing. Monotonic increasing. Now taking nth term an is equal to n. Now taking limit n tending to infinity both sides, this is equal to infinity. It is infinite. Therefore we can say the sum of the given sequence is infinite, hence sequence is divergent. So sequence is divergent. Okay, student?